Now, I had no doubt I already have a video on this website about how to work with ICEE tables and ICE tables, but I kind of wanted to make a crash course one for those of you walking through the equilibrium video series and did not want to have to go find that video. So ICE tables are what you used in Chemistry 1, and we use them in Chemistry 1 because we dealt with irreversible reactions. When we get to Chemistry 2, we start working with reversible reactions. Now, big difference is a reversible reaction does not have a limiting reagent. So we can't sit back and say, oh, that one runs out, we'll use this for all the calculations. The problem is none of them really runs out because it's equilibrium. They have to be there when we finish. So the ICEE table is a way of doing the accounting and helping us figure out what the equilibrium concentrations are. Now, there are 4 rows in an ICEE table. I, here is going to be your initial concentrations. You may be given them, you may be asked to find them, but this is where your initials go. The change here is purely in terms of extensive reaction. So because we don't know how far the reaction went, we're going to represent it with a dummy variable x. X is the extent of reaction, and the property of x is if we take x and multiply it by a reaction coefficient, it gives us moles or molarity of what we're looking at. So in the case of A, it has a 1 in front of it, so we're going to multiply the extent of reaction by 1. Now, for these ICEE tables, by my convention, there are 2 conventions, this is my convention, the change is always negative for reactants and positive for products. The upside to this convention, this will always be true. The downside of this convention is that sometimes you will get negative extensive reactions. This just means the reaction went in reverse. We had too many products and we went towards reactants. As long as you stick to this algebra, you'll be fine. Some structures require you to figure out which direction it goes. If it goes forward, negative, positive. If it goes backwards, positive, negative. Honestly, it doesn't matter. This is just my convention. But getting back to the change row. For B, B has a 2 in front of it, so the change is minus 2x. The C has a 3 in front of it, so plus 3x. The D has a 1 in front of it, so plus 1x. Now we have 2 E rows here, and there's a reason for this. The first E row is the algebraic row. The algebraic row is always a function of the extent of the reaction, and it is always I plus C. So if we are given initial concentrations, it'd be the initial concentration of A minus x, initial concentration of B minus 2x, initial concentration of C plus 3x, initial concentration of D plus x. Sometimes we are asked to solve for initial concentrations. If we are, we just put the variables in. Regardless row, this is always a function of x. The E row down here is the numerical row. For the numerical row, this is a number, and this is either a number we're trying to find or it's a number we're given. So if we're told at equilibrium the concentration of A is 1.8 molar, we put 1.8 here. Or we may be asked, what's the concentration B of equilibrium? Well, this is the number we need to find. The power of the second E row, though, is that it is a number, and it is equal to the function of x. So if we know the number, we can figure out what the extent of reaction is. Or if we know the extent of reaction, we can backtrack out what the actual number is. So these 2 rows are equivalent. Now the other power of the ICEE table, we need an ICEE table to solve equilibrium problems. We also need our expression K Q equals Q in whatever Q is. Now Q is a function of the equilibrium concentrations. Well, we have 2 equilibrium rows here, E and E. If we are being asked to find the extent of reaction, we can plug in the algebraic row. If we're given concentrations and are being asked to find maybe an unknown starting concentration or something to that effect, we can use the numerical row. But the choice of rows you plug in for Q depends on the problem you're solving. But the point here is that whatever expressions we have for Q, we're going to use the values in these 2 rows substituted in to solve our problem. So this is how you set up an ICEE table for any equilibrium reaction. Your initial concentrations, your changes in terms of reaction coefficients and extensive reactions, an algebraic expression for that equilibrium concentration in terms of starting concentrations and extensive reactions, and the actual numbers. How you fill in this table is going to be based on the information that you're given, and what part of this table you're looking for is going to be based on the type of question you're trying to answer.